There's a lot of people talking today about clean energy. You know, we're trying to get energy that doesn't pollute and things like that. So everybody's trying to get away from fossil fuels, and you're hearing about global warming and all the issues around that. And so we're looking for alternative energy sources. And one of the better alternative energy sources is geothermal energy. Geothermal energy basically comes out of the ground. The energy is going to come out of the ground anyway, and all we're going to do is try to capture a little of that and use it. And so it's a real nice, clean alternative. There's no pollution put out by it, and it is constant. So you never have to worry about it not being there, like solar energy or wind energy or anything like that. Geothermal is the best that you could possibly have. So there basically are two types of geothermal energy that we can deal with. There's what is called hot-dry or cold-wet, okay? And so the two types depend on the area that you're in as to which you can use. Now the hot-dry type, that's the best type if you can get it. And so there are places like Iceland or geysers in California or even things like Yellowstone where there's a constant source of high-end energy coming out of the ground. It's very warm. Okay, the cold, wet stuff is everywhere. You don't have to go to specific places, but it doesn't put out as much energy. So the difference is then with the hot-dry is you have to have a magmatic source. Okay, the magmatic source has to give you a lot of heat. And what you do is you circulate water down to where the heat is, and then the water is boiled up into steam. Now, as the steam comes back up, you have pipes that lead the water down and pipes that lead the steam up. When the steam comes up, it comes up with a lot of force. And so therefore, it can turn turbines. And as it turns the turbines, basically then you can generate electricity. So not only can you get hot water out of there where you can heat your buildings and other things, you can also get direct electrical energy out of the hot, dry sources. As I said, you need to have a high energy, a high heat source like magma or a volcanic region or something like that where you can depend on a real high amount of heat, and then that will turn into steam. And the steam is what comes out. So these areas are when you see them, they have a lot of steam in the area, a lot of clouds and things coming out of them. And so that's how you get the hot-dry part. That's the best. But of course, hot-dry you only get in certain areas. The best thing we can do is what we call cold-wet. And now the cold-wet stuff is where you have an area like where we live now. And in cold-wet, basically is if you go down about 6 feet below the ground surface, the temperature is a constant 55 degrees all year. Whether it's winter or summer, it doesn't matter. It's going to be 55 degrees. And so what we do then is we have basically the earth is our source of energy to make that 55 degrees. And what we can do is we can circulate water from whatever we need down to that 55-degree area, and then we can basically work it like a heat exchanger in one of these household heating systems. Okay, it exchanges heat with the earth to where we want it. So this is really useful for houses and things because, say, in the summertime, you can start your air conditioning system at about 55 degrees and cool your house. And basically, you don't need anything else. You don't need a compressor or an air conditioning unit. You're at 55 degrees. In the wintertime, you're starting at, instead of like if it's 20 degrees outside, you start at 55, and then all you have to do is heat from there. So say you want to go from 55 to, say, 70. It's only 15 degrees, as opposed to going from 20 to 70, which is 50 degrees. And so therefore, only having to heat a little bit means that you can save a lot of energy that way. Now, some of the school systems we have in Newark actually use this. So Science Park High, for example, has the well field out in the back of the school, and it circulates water and has a whole system that helps cool and heat that school at minimal cost. The new Central High also has a geothermal system in it as well. So all of the newer buildings that are trying to become energy efficient are actually using these systems. Okay, so here's our geothermal setup. we have two parts to this. The first part over here is kind of a kitty litter pan full of sand and water, and this represents the Earth. This has you can see these hoses coming in here. It has a coil of copper tubing inside of there, and that's our radiator that goes into the ground. Okay, and you'll see that this tube has water in it, that it circulates through that copper tubing so it can take on the temperature of the Earth. So this is our Earth, this is our source of our energy. Now where this is going to go, and this is at room temperature. So we can measure that room temperature here with this thermometer. Now the next thing we're going to do is we're going to move over here to the other part, and this is a container of water that's been in the refrigerator. So this water now has a refrigerator temperature more like in the order of 30 degrees or something like that. You'll measure it using this thermometer to see what that has. And so what we're going to do then is we have a pump in between these two. And we have a copper coil in here. That's the radiator for our house, or in this case our water. And we have a copper coil down in the earth, and we're going to circulate water between the two. And so we can transfer the heat from the earth up into our water container here, which represents a house. And so what we're going to do in this exercise is basically we're going to turn on the pump, we'll take our temperatures to begin with, and then we're going to turn on this pump and we'll start the stopwatch, and every 2 minutes we will then take a measurement and see what the temperature is. And so then we're going to plot these measurements that we get with time on our graph, and we're going to see how temperature changes with time in here versus here.